on the Unit 12 review, we're on number 4. This is the section where we're adding and subtracting rational expressions. If you need the 3 prior to this, the subtraction ones, you can go to the previous video. Here, these 3, 4, 5, and 6 are all addition. We can see they're all 2 rational functions being added. But we know when we add or subtract rational functions, we must have what? A common denominator. In number 4, we do. We already have the same denominator, 2x squared, for both of these. So you can simply add the numerators. So what's 6 plus 11? Oh, I just said 6 plus 5 is 11. My bad. All right, so we add the numerators. And we have our common denominator. Now, if you can factor either your numerator or denominator, you look to factor that and reduce. Neither of these factor, nothing, 11 over 2 doesn't reduce. That's it. That was like the easiest problem on the review, I think. Okay, there was no factoring, no getting a common denominator. All that was already done. So pretty simple, straightforward one there. Just understanding that when you add fractions, you don't add the denominators. You get the common denominator and it stays. Okay, you're only adding the numerators. All right, in number 5, though, we do not have a common denominator. So we need to get a common denominator. This binomial x plus 6 cannot be turned into an x, and x cannot be turned into x plus 6. So we have to multiply them by each other. So this side is going to get multiplied by x. And what you do to the denominator, you do to the numerator. So you're multiplying the top and bottom over here by x. And then this side is going to get multiplied by the x plus 6. Top and bottom. Okay. So when we multiply on the left here, we've got a binomial times a binomial. X plus 6 times 5x plus 2. So you have got to do some distributing, double distributing. I'm going to come down here so we can draw some arcs. So we've got to distribute the x to both of those. So that's going to be 5x squared plus 2x. And then we've got to distribute the 6 to both. So that's 30x plus 12. Okay, and that's all over this new common denominator of x plus 6 times x. And it doesn't matter if you write the x first or the x plus 6 first. Okay, now this is being added to same denominator. And to simplify in the numerator up here, it's just a monomial times a monomial. So 2x times x is 2x squared. All right, so I'm going to go ahead and know that I'm combining my numerators. I'm adding those together. So I'm just going to combine like terms up here. So I've got 5x squared and 2x squared, so that's 7x squared. Okay, and then I've got 2x and 30x, so it's 32x. And then I've got plus 12. All over this common denominator of x times x plus 6. Now, once you've got your numerator all combined, if it's factorable, you want to factor it to see if there's any common factors in the numerator and denominator that you can reduce. Okay, now I can't reduce anything the way that it's written right now. I don't see any factors in the numerator. So factoring your trinomial, we've gone over, I don't remember what unit it was in, but we did a factoring review before quadratics, I believe, or during quadratics. It was, we did guess and check, we did grouping, we did box method. So you can choose your factoring method when you want to try to factor. I tend to just use guess and check, but you don't have to if you want to choose a different method. Okay, so I'm going to see if I can factor this numerator. The only factors of 7 are 7 and 1. So it's got to be 7x and 1x. Now, the factors of 12, it could be 12 and 1, 6 and 2, 3 and 4. Okay, so I have actually a handful of things I'm going to have to guess and check until I see if it works. Now I can figure out my signs right away. It had the factors of the 12 have to multiply to a positive. And in the middle here, once we add them together, they need to add to a positive. So I do know these should both be positive. These should both be plus. Okay, now we have to remember, because of that 7, it's not what multiplies to 12 and adds to 32. It's what multiplies to 12, and then the one that goes in this spot here on the outside is going to get multiplied by the 7. And the one that goes here gets multiplied by this understood 1. Okay, and then they add to 32. So this is why guess and check. You don't have to write anything down yet. Let's check. Okay, so if I did 12 and 1, that would be 7 and 12. That's 19, not 32. So 7 and 1 or 12 and 1 in that order don't work. And then if I can just tell you, if I tried to do 12 at the end here, 12 times 7 is way too high, right? So I know 12 and 1 are not going to work. Okay, so then, okay, what about 6 and 2? If I put my 6 here, 7 times 6, that's still too high because that's 42. That'd be 44. That's not it. Okay, and if I switched it and did 6 and 2 this way, 7 times 2 is 14 and 6, that's only 20. So that's not going to work. So they say, okay, 12 and 1 don't work. 6 and 2 don't work. What about 3 and 4? So if we try 3 and 4, what's 7 times 4? 28. And I add 3. What does that give me? 31. So close, but it's not it. It's not 32. Okay, and if you need to check them, some of you can check in your head, some of you need to see it. If I tried to switch it, this wouldn't work either because that would be 21 and 4, that'd be 25. So what I have found here, guessing and checking, I checked all the factors of 12, didn't I? That was all of them? There's none I haven't checked, is there? That was not factorable, was it? So we can't factor. So that means nothing will reduce, that this is it. You feel okay about that? Now, in these expressions, I mean, these are just expressions, not equations, but if you were asked about this expression, about restrictions or excluded values, what would be your excluded values here? How do you determine the excluded values or the restrictions? What can your denominator of a fraction not be? Cannot be 0. You cannot divide by 0. So what values of x would make either of these factors 0? If it's just an x, it's a 0, right? If I plug in a 0, that's going to be 0. But what about here, this x plus 6? What would make that expression 0? A negative 6. So 0 and negative 6 are your excluded values. That's what x cannot be. If you were to try to graph this, those would be your vertical asymptotes. You'd have 2 vertical asymptotes in this one. Y'all with me? All right, don't forget, I didn't show you on number 4. I'll show you here on this one. You can check if you're not sure, especially in one that like you thought you were trying to factor and it didn't work. It was a little more complicated. 4 was not complicated, but this one was a little more complicated. So if you're unsure, you can always check your work in Desmos. So you can type in your original equation was given 5, or your original expression, excuse me, 5x plus 2 over x. And then it was plus 2x over x plus 6. And then type in what you got. X times x plus 6 in the denominator. And 7x squared plus 32x plus 12 in the numerator. So type in the way that it was originally given to you and what you got, and those graphs should be identical. And if you turn this one on and off, you can see it is. It just graphed right on top of the original one, didn't it? And we can confirm what we just said, that the restricted values would be -6 and 0. That looks like where these vertical asymptotes are, doesn't it? So if you were asked a domain question, you would know that -6 and 0 are where the breaks in the domain would be, right? You feel okay about these? Okay, let's try that last one on this section, number 6. All right, we've got x plus 3 and x minus 4 as our denominators. They are not the same. We have to get a common denominator. We're going to have to multiply them by each other. So this side is going to get multiplied by x plus 3. And this side is going to get multiplied by x minus 4. All right, on the left, that 2 gets distributed in the numerator. So that's 2x minus 8 over my new common denominator. And actually, you know what? You don't have to even, like I did here, I wrote them separately with the common denominators and the plus sign in between. I can go ahead, when it's addition, I can go ahead and just write this all as 1. So I'm just going to write the denominator once instead of twice. I'm going to go ahead and combine them kind of all in one step here. Okay, so now I've got this plus sign. Now I do need to do some distributing up here because we've got a binomial x plus 7 times x plus 3. So we got to double distribute. So that's going to be x squared plus 3x. And then that's going to be 7x plus 21. Now I'm going to combine like terms in that numerator, simplify this up. So I only see one x squared term, that's x squared. I've got 2x, 3x, and 7x, all positive. So that's 12x. And I've got -8 and positive 21. So what is that? What does that give me? What's 21 minus 8? Y'all can participate here. Say again? 13. So we've got plus 13. Now I can tell you right away, this is not going to reduce, like, because what are the only factors of 13? Because 13 is prime, right? It's 13 and 1. 13 and 1 is not going to combine to 12. It would combine to 14. So I know, and I can say that really fast because this A is an understood 1. Okay, so I know this is not going to factor. I'm not even going to bother trying it because I can see it right away. So it's not going to factor. That's as far as we can take it. What would the excluded values be here? If you were asked for the domain. Say again. -3 and +4. Remember, it's what would make these factors 0. So it's the opposite sign that you see there. So a -3 and a +4 would be the breaks in the domain. That's where your vertical asymptotes would be graphically. Okay, and we can check one more here. So you can see that was 2 over x plus 3 plus x plus 7 over x minus 4. And then we came up with x squared plus 12x plus 13 over x minus 4 times x plus 3. Okay, so if I turn that on and off, that's the exact same graph, right? And we can see that where the vertical asymptotes would be here at -3 and here at +4. You'll feel okay about that? All right, good. So adding and subtracting expressions done. If we flip over to the back side now, we're getting into dividing rational expressions. Okay, so dividing rational expressions, we have to remember we do not need a common denominator to multiply and divide. We just need that to add and subtract. But when we divide, we want to remember to keep, change, flip. Meaning we keep the first fraction as is, like the numerator and denominator stay where they are. Then we change the sign from division to multiplication, and we flip the second fraction, the second rational expression. Okay, so when I write, and I want to factor everything, factor both numerators and both denominators. So nothing to factor in the first one. So it stays x cubed over 5. But I change it from divide to multiply. And then I flip this one. And when I flip it, I'm going to factor 2, but there's nothing to factor in either of those. But now I look to see, can anything reduce? So do you see a common factor or some coefficients that might reduce in the numerator and denominator? There's no x's to reduce with any of these x's up here, but what about the numbers, the coefficients? Can't those 5s reduce? Yeah. 5 over 5 is going to reduce. That's just a 1. I don't have to write a 1. So when I multiply across, you can multiply straight across the bottom, straight across the top. So x cubed times x squared. When you multiply like bases, you add the powers. So that's x to the 5th over 2. So far, so good? I'm just going to pull up these notes to refresh your memory. We'll go back to solving those. Okay, when we were, oh, this was adding and subtracting. Go back to multiplying and dividing. We did the same thing. When we multiply or divide, it doesn't matter. Oh, that was simplifying. Okay, so multiplying, dividing, okay. We've been writing these expressions. We wrote the excluded values. I just talked about the excluded values with adding and subtracting. Maybe we should go back and add the excluded values. But in this one, are there any excluded values? Is there an x in this denominator? No, there is no x in this denominator. So I do not have an excluded value. So there is no restriction in this domain. Okay. All right, up here, I'm just going to come back here because I did not list my excluded values. I just talked about them. I should go ahead and list them. So I'm going to say what X cannot be. Here, X could not be 0 because 10 times 0 would make that 0. Okay, here, X could not be 0 or 9. That's what would make either of those factors 0. Here in number 3, X could not be 5 or 3. And in the ones that we did together in this video, here X could not be 0 is what would make that factor 0. And then we talked about it here. We said it couldn't be 0 or -6. And then here we just said it could not be -3 or +4. I apologize. I should have been listing those the whole time. Okay. Well, let's take a look at 8. Keep, change, flip, but we have to factor. Number 7, there was no factoring to be done. It was a little more straightforward. But here, I can factor my denominator. X plus 3 cannot be factored. That's just it. But this one can be. X squared minus 9. That is a difference of 2 squares. Remember, dots factoring. Difference of 2 squares means it's difference. It's a subtraction. And they're both 2 perfect squares. So those factor into 2 binomials that are nearly identical. One's a plus and one's a minus, though. So the square root of x squared is x. And the square root of 9 is 3. I'm keeping my numerator as my numerator. What in the heck? Oh my gosh. Okay. Highlighting is not going to work on this. I don't know what the deal is with this highlighter today. It is not letting me highlight in the pre-typed stuff. So I guess I won't bother. All right, but I kept that rational function. I kept the numerator and denominator where they were. I just factored. Now I'm going to change the sign from division to multiplication. And now I'm going to flip this fraction. So what was in the numerator, x squared, is now in the denominator. And what was in the denominator is now in the numerator, but that can be factored. So I'm going to factor it in the numerator. Okay, so x squared will factor to x times x. And since that's an understood one, we're just asking ourselves what multiplies to 18 but adds to -9. So it multiplies to a positive but adds to a negative. We can straight away know they must both be negative. Okay, so what are factors of 18 that add to 9? 6 and 3. Good. Now I did my keep, change, flip. So now I'm ready to reduce. Are there any common factors in the numerator and denominator that I can reduce? Across the board, okay? It doesn't have to be in the same rational expression because we're multiplying them. You can look across at one numerator and the other denominator and vice versa. X plus 3 for sure, here and here. Anything else? What about the x minus 3? Got an x minus 3 here and here. Numerator and denominator. That's what I mean when I say you can go across the fraction. When it's multiplication, that's fine. You can still reduce that. So everything over here is gone. Both of those just reduced to ones. There's still things left in both the numerator and denominator, so I'm not going to have to write 1. But that's going to come out to just be x minus 6 over x squared. Now, I still need to list my excluded values. Okay, definitely here, I can't be 0 because 0 squared would be 0. Okay, but you still have to look at what you reduced as well. So I read from the denominator, it was an x plus 3 and an x minus 3. So what would have made either of those 0? What could I plug in here to make this expression 0? What could I plug in to x plus 3 to make it 0? Well, I'm not plugging in an x, I'm replacing x, but yes, with a -3. -3 plus 3 would be 0. So -3 is a restriction. It's an excluded value. What about x minus 3? What could I plug in for x that would make that expression 0? A +3. So positive and -3 are excluded. You can list them separately, or you can just do the plus or minus. But those are my excluded values, or my restrictions on the domain. And actually, I want to show you in Desmos. I showed you in Desmos with the adding and subtracting. I want to show you with the multiplying and dividing. You can also check these graphically. So if you're unsure, so I'm doing number 7 right here. Okay, so we've got x cubed over 5 divided by 2 over 5x squared. Let me get rid of that one. Okay, so this is what we've got. Okay. So here's that. Now I want to see, does it match what we came up with, which was just x to the 5th over 2? There it is. So you can do the same thing with multiplication and division, but this is what it's going to look like when you set up the division. They're not going to have this division symbol. It's going to write it as the fractions within fractions. Okay, so I just wanted to make sure you saw what that looked like. All good? So you can check those in Desmos as well. All right, last dividing one. We need to keep, flip, change. So I'm going to keep the first fraction as it is, and there is nothing to factor in 5x or in x plus 3. I'm going to change it from division to multiplication, and I'm going to flip this fraction. Now, the x squared minus 9, that is a difference of squares. We just factored that in an earlier problem, but now it's going to go to the numerator, and it factors to the x plus 3, x minus 3. Now, what was in the numerator now goes to the denominator, and I'm going to try to factor that. So x squared would be x times x. So factors of 15 that add to -8. So first of all, it multiplies to a positive, so it has to be the same sign, but adds to a negative, so they must both be negative. So are there factors of 15 that would add to 8? There it is. Good. All right, now reduce, if possible. Is there any common factors in the numerator and denominator? X plus 3, x minus 3. That's it. So I'm left with 5x over x minus 5. But I do want to list my excluded values. X cannot be, okay, with what's left here, x minus 5, what could x not be? It's x minus 5. So what number could I not plug in here? Positive 5. So definitely 5 is excluded, but then I got to look back at those that were reduced. It's the same ones that were reduced in an earlier problem, the previous problem. So it's going to be -3 and +3 are excluded as well. And you can check that graphically if you need to as well. Or if it was multiple choice, you could check, plug in the original, plug in the answer choices and see which one matches. All right, multiplying I think is the easiest. You don't have to get a common denominator. You don't have to flip anything. It's just multiply straight across the top, straight across the bottom. Now, you still have to be able to factor for ones that are factorable, okay? But in number 10, nothing factors in either numerator or denominator. So I'm ready to just multiply straight across the top, straight across the bottom. So what's 7 times 6? 42. Okay, and on the bottom, when you're multiplying monomials, you multiply the coefficients and then you multiply the variable that's the like base. So what's 9 times 7? 63. And the x squared times x is x cubed. And I just realized something. I could have reduced first because now I just realized I should have. Okay, so I'm actually going to erase that. You could multiply first and then reduce, but it was already in the perfect setup for reducing, so I should have reduced first instead of doing extra work. Look at those numbers. There was no variables that reduce from the numerator and denominator, but look at the numbers. There's sure some reducing I could do. What's going to reduce? What? Yeah, the 7s, go ahead and knock them out. Those go ahead and reduce. What about the 6 and 9? Don't they have a common factor? So you can reduce that as well. What will that reduce to? Yeah, the 6 over 9. If I divide out a 3 from both of them, I'll be left with a 2 here and a 3 here, right? 6/9 reduces to 2/3. Now I'm going to go ahead and multiply straight across, and I'll just be left with 2 over 3x cubed. I do still need to list my restrictions. X can still not be 0 because that's what would make that denominator 0. All right, let's factor to see if we can reduce. So factoring x minus 3, no factoring. But in that denominator, let's see if we can factor that quadratic, x squared. And then factors of -24 that add to 5. So the fact that it multiplies to a negative tells me I've got to have one positive and one negative. Okay, so factors of 24 whose difference is 5. Factors of 24 whose difference is 5. What multiplies to 24? 8 and 3. Good. Okay, so +8 and -3. Okay, now in the second fraction, I still need to factor. In the denominator, I can factor out a GCF of 7, and that would leave me with x minus 7. And in the numerator, that's a difference of 2 squares again. That's x, and the square root of 64 is 8. So one positive and one negative. So this is where I'm at. It's all factored. Now I'm ready to reduce, if possible. What'll reduce? X plus 8, x minus 3, and that's it. So I am left with, when I multiply straight across, that's just x minus 8 in my numerator, and 7 times x minus 7 in my denominator. What are my excluded values? What can x not equal? Second. No, that would make the numerator 0. It's fine if the numerator is 0. I don't want the denominator to be 0. What would have made this one 0? -8, right? So a -8, a +3, and a +7. Those are the excluded values. That's what would make, what the heck? Why does my box keep erasing? That's what would have made these factors in the denominator 0. Y'all feel okay about that? All right, I think this is the last multiplying one. So same strategy, factor everything. So the numerator on the left, it multiplies to a negative, so I know I'm gonna have one positive and one negative. Okay, what multiplies to 16 but has a difference of 6? Multiplies to 16 has a difference of 6. Yeah, 8 and 2. Okay, but again, I want it to come out to -6. So it's the 8 I want to be negative and the 2 I want to be positive. All right. The numerator up here cannot be factored, but the denominator is a difference of 2 squares again. What's this? What are these going to what's it factor to? Difference of 2 squares becomes what? What's the square root of 4? Square root of 4 is 2. So it's +2 and -2. All right, so now I'm going to reduce. I see an x plus 2 in both, so that can go. And I see an x in both. That can go. Nothing else is going to reduce. So my numerator, I'm going to have 2 times x minus 8. And I'm going to just have x minus 2 in my denominator. My excluded values. So from what's left, definitely cannot be a 2. And from what I eliminated, it couldn't be a -2 either. And it couldn't be a 0. So I'm actually, instead of writing 2 and -2, I'm just gonna put plus or minus 2 and 0. Now feeling okay about multiplying, dividing, adding, subtracting? All right, I'm going to stop this video here. I'll do another video with the rest of the review is solving. But again, all of these that we just did in this video and in the last video with multiplying, dividing, adding, and subtracting, all of those can be checked in Desmos. You're checking to see if the graphs are the same. And if it's a multiple choice question, you can plug in the original expression, whether it's add, subtract, multiply, or divide, the whole expression, and then your answer choices and see which answer choice matches it. So really, there's no reason to miss any of these simplifying ones on the test because you can check them all in Desmos. Okay? You'll feel okay about those? I'm going to stop that video here. All right, we've got